For the eclipse, we have two papers coming up on citizen science. The first by Hugh Hudson about the Megamovie, and then we'll hear Dr. Rita Holbrook about a movie that she has made, and then we'll hear Matt Penn about other citizen science, about this so-called Citizen Kate. So let us start now with Dr. Hugh Hudson and colleagues about the Eclipse Megamovie.
Thank you, Jay, and the colleagues included Jay. Eclipse Megamovie was a program basically centered on the idea of upload, not download, involving many volunteer observers armed with DSLR cameras and telescopes and consumer electronics. So the idea basically was to capture all of the images that anybody took during that eclipse and to make them into one giant data cube, which we would archive. We didn't quite succeed in getting all of the images, but we have a lot of them. And so then, having done this outreach-centered activity with volunteers, maybe 15,000 of them, now we have data, and we have these people, many of the same people working on citizen science analysis of the data. So this talk now is basically about science. The first thing here is something that came up as soon as we got our SQL Public Archive available, which took a couple of months, and for that we have to thank, for doing it, we have to thank Google, who was really our sole means of institutional support. That SQL archive is there online, and within a week, this particular volunteer had come onto it, learned how to understand SQL, still beyond me, and to make a Google map out of this. So if you observe the eclipse, you can go to his map and locate your own pinprick site, as long as you had accurate GPS coordinates. Right, so what we did, the answer to the question in the title, and the question actually is not what did we do, but it's what did they do, being those 15,000 people. The answer is they succeeded, okay, and are succeeding. And these are the links to our public domain things at the top. The source code is on GitHub for all of the work. The data set itself is on this SQL archive on the Google Cloud platform, which is freely available. And then this universe is now running our first science program with these data. You can look at the URL, the landing page, Google's homepage for Megamovie, which is eclipsemega.movie. And you can see their movie, which was basically just a composite movie of all the different heterogeneous kinds of data that come through, not a registered movie of the sort that Matt will show you from Citizen Kate, but we'll work on that. And it's not easy to make a movie, as you all are aware. It shows all the flaws, and in our case, it was self-inflicted flaws because we accepted such a wide range of data types. So, but one of the nice things about Megamovie, of course, is that we have many images that include the star Regulus, right? And so between Regulus and the moon itself, there is a full astrometric background for reduction of many of these images. And Regulus, of course, saturates. This is a quarter of a second image. This is the very first one, actually, in the SQL archive. It's quite nice. You can see that the star itself is saturating, but it's tightly measured. So the observer did a good job of focus. All right, and so that's a real asset for analysis. And Shadia, when I showed this in New Orleans, Shadia pointed out that one of these is upside down. This is the same image. One of these is the same image, but it's now sharpened with the Morgan-Drickmiller image sharpening algorithm. So you can compare this, and it's of course the reverse color table as well, with this, and you can see that there's a whole lot of structure that comes up. It's there in the images. There's plenty of signal-to-noise ratio. This is a very solid observation. And so those streamers extending way out there away from the sun can be monitored over these 90 minutes of the eclipse through this database. Another aspect of this was the app. We made an app for smartphones, and there is my observatory on the right in Corrales, Oregon. It consists of 10 iPhones. And on the left, you see a picture of Matt Bender, another one of our key people in Patagonia, practicing on the annular eclipse there in February. And you can see attached to one of the smartphones there on the left of that image, there's a lens. And we were hoping, we did not succeed in getting a lot of people to put lenses on their smartphones, and we'll hope that in 2024 that we'll have much more distribution of that good idea. All right, so the thing about the moon is that now we know exactly where the moon is. Even Watts, yeah, this is the traditional Watts marginal zones of the moon from the 1950s. Now we know where the moon is to about 10 meters precision, exactly, on all scales. And so what the moon's presence does, because it has this rough structure around its limb, arc seconds in scale, it makes Bailey's beads and the diamond ring. And these are tools that we can use to do science. So I'm just going to wind up here with one slide, which I didn't show in AGU. This is new, so people shape up. If you were there at AGU, let's look at this slide. This shows programs, science programs that we're working on now through the citizen science volunteers. One of them will be, it isn't yet, one of them will be the geolocation and timing of those Bailey's bead images and the diamond ring effect to do this solar precise astrometry. And this is a takeoff from the kind of work that IOTA does, the occultation array. So many people have been working on this kind of thing in the past. The new thing here is the parameter space of having 90 minutes worth of data, the brute force approach to doing this with many, many sites. That's program number one. Program number two is pinning our coronal imagery to Regulus, which we can do with all of these images, with most of them. We can actually make very precise relative motions for these streamers. So this is a very important fishing expedition, because in between the sun and the solar wind, there's the coupling of angular momentum. The torque is imposed by the magnetic field. We see evidence of this field through these streamer structures, and so motions of those structures may give us important information about that basic physical property of the stellar spin down in the case of the sun. Item 3 is, of course, we don't know what we're going to get from this very high signal-to-noise ratio. In red here, I'm showing you the new thing that this program brings. We're not doing new kinds of observations to do science. What we're doing is expanding parameter space by having a lot of data. And the expansion includes this precise geolocation and timing from GPS. It includes the presence of Regulus, a star, and it includes basically huge oversampling. And that's something we haven't had before. So anyway, that's the end. It worked. It is working because we're working on a volunteer basis through Zooniverse. And I think that having a public archive of imagery is a very important thing. It was done for the first time through this program for this eclipse. I think it should be done for every eclipse for future reference, and also for the science that comes from this extension of parameter space, so especially in 2024. Thank you.
Thank you for that interesting report. A question? Questions? Yes, Lika?
Good stuff. I almost didn't believe, but some of the samples you showed are pretty incredible. So you said these data are available on the website, and they are, I guess, whatever you mean by calibration, there are some information, so if people wanted to use this information, they could?
Absolutely. It's perfectly public domain, and people are already using it through this Zooniverse interface. It isn't professional data of the sort that many people would get in the sense of imagery. It's just images, just photographs. And we, as I said, we'd hoped to capture everybody's images, which would have meant we were in the petabyte upload situation as opposed to the petabyte download situation that NASA promoted that Alex mentioned. So we got instead only a terabyte.
Are you applying that image enhancement technique to all the data? Or
yes,
that
we've already done that. That's straightforward.
Right? I'll take a look. Thank you.
Right.
Very interesting.
Thank you. Thank you very much. And if you'll take a look, that's a good example. And let's everybody take a look. Thank you very much. Thank you. Our next speaker